Assalamualaikum, my name is Noraslin. I'm going to show you guys on how to plot the control chart for P chart for question number 1 by using Microsoft Excel. Okay, let's see the question here. I was given 4 columns or sample number of inspected items, number of non-conforming items, and proportion non-conforming. Okay, first I will transfer all the data into the Excel. So this is the data, and then I add 3 more columns, which is the center limit, upper control limit, and lower control limit, to make it easier for me to plot the chart. Okay, how to find the center limit, upper control limit, and lower control limit is by using these 3 formula. For the center limit, P bar, the formula is by dividing the number of non-conforming items by the total number of inspected items, which is 1250. Okay, for the center limit, 90 divided by 1250, we got 0.072. And for upper control limit, P bar plus 3 square root P bar times 1 minus P bar over n, we got 0.181667133. And for the lower control limit, negative 0.0376667133. And then I put them in this column. And for the chart, how to plot the chart, first we have to highlight these 4 columns of proportion non-conforming, center limit, upper control limit, and lower control limit, because all we want in that chart is this 4 proportion non-conforming, center limit, upper control limit, and lower control limit. And then go to insert and click on recommended chart and choose the line chart. And here is the chart that we got for the P chart. Okay, so this is the chart. As we can see here, the yellow line is lower control limit, negative 0.03767. For the upper control line is the gray line, 0.181667, and the orange line is the center limit, which is 0.072. As we can see here, the sample 18 exceed the upper control limit, so we have to recalculate the center limit, lower control limit, upper control limit, but this time we have to eliminate the 18 sample. But I'm not going to show it in this video because I'm going to show how to plot the chart only for this video. Thank you.
Okay, so let's continue with the control charts for the attributes. Okay, so this is the NP control charts. Okay, what is the purpose for the NP control chart? The NP control charts purpose is to plot the number of non-conforming items in a sample. Okay, so these are all the formulas for the NP chart, the center line and times P bar. The upper control limits NP bar plus 3 in the square root NP bar times to the 1 minus P bar. Then the lower control limit is just the same as the upper control limit, just minus. Okay, so that's the difference. Okay, so now you have to take note. If the lower control limit is less than 0, then it is converted to 0. Okay, so let's look at the example. This is the question given. The question number 2. Okay, so this is it. It is about the number of dissatisfied customers in a department store observed. Okay, so there are 20 samples of size 300, as you can see. Okay, then you do the NP chart. Okay, so what I did, I did the NP chart in RStudio. Okay, so this is the coding. First, you start with the library QCC, the package for the quality control chart. Then read the table. Okay, so I haven't shown you the table yet. Okay, let's start with the table first. Okay, so this is the Excel that I have done. These are the data from the question. I put it in Excel. The D in this is the number of dissatisfied customer. I put it as D to make it easier in the coding. Then the N 300 is the size given in the question. Okay, so in the R studio, I did a function read table to read this table, this Excel table that I've done. Okay, so this is the path to that Excel. Then you attach the data, do the function data again, then the data will appear in the R console. Okay, so this is the same as in the question and in the Excel. We just make it appear in the R console. Then do the function QCCD, which is the number of dissatisfied customer. Type in this case is the NP chart with sizes of 300. Okay, so that's all. You get the NP chart in the RStudio plots. Okay, so this is it. There are 20 samples. Okay, so what we have here is there is one out of control point. Okay, this is it. There is one out of a control point, which is it is the 12 point. Okay, so what we need to do now is if based on the question, the department store, they need to take note on the 12 point. They need to find they need to do something about the special cost. They need to do something about the special case, sorry. Okay, so the special cost should be found and eliminated. So that's the case, and they need to find the why, the reason why, the cause. They need to find it and eliminate it. Then the efforts at reducing the amount of the causes, the common causes of variation can begin. But to improve it, you must know what errors occur most frequently. Next, you can do other analysis such as Pareto diagram on the reason for the invoice errors. Okay, so this is it. The MP chart in the RStudio. Okay, so now I'm going to show you the MP chart that I've done in Excel. It is just the same thing as in the RStudio, but the way to do it is different. Okay, so these are all the data. These are the number of dissatisfied customers. Then I do the calculation, the formula in the NP bar. In this space, I do the calculation the same as I showed you before. Okay, so these are the upper control limit and the lower control limit. The formulas are here. Then after that, you just drag all this data, not included the sample. Okay, so right click, then do the quick analysis, and you find the charts. Okay, so this is it, the line charts. Okay, so then you can do the okay, so this is it. Next, you can adjust it and mark all your points. I'm not gonna show you how I mark the point, but I'm just gonna go straight to the MP chart that I have done. Okay, so this is it. It is the same as in the RStudio. There is one out of control point. So what we gotta do is the same as what we gotta do is like I said before, they need to take note on the 12 point and then find the special cost, then eliminate it. After you've done that, then you can do the formula, you can do the steps to reduce the common errors. Okay, so that's it for the NP charts. Thank you.
Hello everyone, my name is Nathaniel and I will explain for the question 3. So question 3 is we need to construct a C chart for the number of non-conformities. Firstly, we need to run the library QCC in order to use the function QCC. And we assign that the C.data is the data we obtain from the questions given. So as you see, there are a total of 25 data together. And as the sample of fabric from a textile mouth each 100 meters square are selected, so the n will be equals to 100. And now we use the QCC. So the data is from the C dot data that we assigned just now, and the type is equal to C as we need to construct a C chart. So we run the graph. So from the C chart, we can see that there are a total of 25 groups together, and the center line is 7.56. And the lower control limit, suppose if we calculate it, we will get negative value, but we can just assume it as 0, and the upper control limit is equals to 15.8086. So from the chart, we can see that there is a red point, and this red point will indicate that there is 1 point out of the control. So we need to delete the data. So it is data number 9. So the new C dot data will contain 24 data together, and the n is still equals to 100. And now we run the new C dot data. So from the chart, we can see that the number of groups is equals to 24, and the central line now becomes 7.2083, and the lower control limit, we will still get the negative value, but we can just assume it as 0, and the upper control limit is 50.2628, and all the 24 points is in the control limit, so we can say that this process is under control.
Hello everyone, my name is Ruiwan Ling. So now I'm going to discuss question number 4, which is construct a control chart for the number of non-conformities per 100 meters square. So now we are going to construct a U chart. From the question, the sample amount inspector Ni and also the number of non-conformity Ci is given. So our first task is to calculate the Ui. The formula of Ui is known as the Ci over Ni, and this data of Ui will be used to construct the control chart later on. So for our first U1, we take 5 over 2, and then we will get 2.5 as our U1. And for the U2, U3, we need to calculate one by one. And after we get all the Ui, we will also calculate the CLU. The CLU is known as the U bar, and the formula is sum of I equal to 1 until the subgroup size, which is 20 of the Ci, over sum of I equal to 1 until subgroup size 20 of Ni. So from this question, we will get sum of the Ci, which is 192, over sum of Ni, which is 41, and then we will get our CLU 4.68. After that, we need to calculate for the UCLU, which is the upper control limit of the data. We use the formula of U bar plus with 3 multiply with square root of U bar over Ni, which is the upper control limit. And for the LCLU, lower control limit, we use U bar minus 3 multiply with square root of U bar over Ni. So since in this question, the sample size Ni is different in each subgroup, therefore we need to calculate the UCLU and the LCLU one by one, and these two will get the different value. Okay, after that we use the UI, CLU, UCLU and also the LCLU to construct our control chart. This is our U chart for the number of non-conformities per 100 meters square. Okay, this line will be our upper control limit, UCLU, our lower control limit, LCLU, and also our U bar. And this blue color line will be our data, UI.
Okay, so from this graph, we can see that for the group number 7, the sample number 7 is higher than the upper control limit, so that we can know that the data is out of control. So we need to delete this sample number 7, which is this whole data, and recalculate and redraw the U chart again. So this will be our new table. We use the same formula to calculate the UI, CLU, UCLU, and also the LCLU. So now our sample will be 19, but not 20, since we delete one sample already. Okay, so this is our U chart, number of non-conformities per 100 meter square, our upper control limit, lower control limit, and also the U bar. So from this graph, we can see that all the data, which is all the UI, is under the control limit, is under the range of the upper limit and also the lower limit. So we can end our process here. This is our full U chart for the number of non-conformities per 100 meter square. That is all for me. Thank you.
Very good morning to my doctor and my friends. So today I'm going to talk about the question 5 here. So this is our question. I have already write down all the data here. So there are 20 samples in this question, and then each sample size is 10. And the weight for this serious non-conformity C1 is 50, and then for the major non-conformities C2 is 10. And for the minor non-conformities, C3 is 1. So by that, we use the weight times this first row, the first sample here, 50 times 1, 10 times 4, and then we use 1 times 2. Finally, we get 92 here. As we stated here, the formula sum of 50 times B2, 10 times C2, and 1 times D2 here. So with a simple click, we get the rest of the data until the 20 sample here. So after we get a total demerit D, and then now we are going to use the to get the demerit per unit, which is the U. So it's very simple. We use this 92 divided by 10. As we said before, the sample size here is 10. So just use the total demerit here divided by 10, and we get all the data here. And then next, we calculate the center line of U chart. So we use a bit of formula down here. So you can see, firstly, we calculate the U first. What is the U? The U is actually the average number of the non-conformities per unit. So U1, look at the series non-conformities here. We use the total there are 9. So we use 9 divided by 20 times 10. And we found that it is equal to 0.045. And next we use this 74, and then we divide it by 20 times 10 equals to 0.370. And then for the U3 we use 114 divided by 20 times 10, we get 0.570, sorry. And then we can look at here how to use Excel. We just use B22, row B22 here, and then we divide it by 10, divided by 20 times 10, and by that, so we can get here. And next, look about the central line of U chart. It's also very simple. We use 50 times U1, which is their weight, and 10 times U2, and 1 times U3. And finally, we get 6.52. And show here, this is the sum of them. So next, we find the variance. Just use 50 square, the weight square, times the C47, which is their U1 bar, then the U2 and U3, and divided by 10 at the end, and then we get their variance, and just put a big square root on it, and then we will get 3.87. And next, the UCL is so easy. So we use the 6.52 here, and then we plus 3 times the standard deviation here, and then we get our upper center limit is 18.14, and then the lower center limit is negative 5.10, as this formula is minus 3 times the estimated standard deviation of u. So as the LCL is smaller than 0, and then we will assume that the LCL is equals to 0. And so our data is like that. So by using the data from here, demerit demerit per unit U center line chart, and then we create our U chart here. So you can see the upper CL is 18.14, and then the center line is 6.52, and the lower center line is the 0, and then the blue line will be our demerit per unit U. So that's all from me. Thank you.
Now I would like to explain about the control charts for the mean and range, which is from the example 1. So as usual, we need to run the library QCC to use the functions QCC. And I would like to import the data set from the txt file, and the data is given from the questions, and I assign it as my data. So, and I run it. There are a total of 125 observations together, and the number of samples is 25. In this case, I enter the observations one by one, and as you see, the sample, the 1 to 5 is the observations from sample 1, and 6 to 10 is the sample for observations for sample number 2, and as follows. And now we need to find the average observations for each sample. So I use the functions aggregate, and this one means that the observations versus the sample. Then for each sample, we need to find the average observations. In this case is average ohms for the sample, and the data is obtained from my data that I assigned just now. So, and I run it. So you can see now for the observations, the sample 1 is 21.6 and sample 2 is 19.8, and this one means the average value for the ohms for each sample. So there are a total of 25 samples together. And now I would like to attach the data. So I use the functions attach, and this one will mask over the data that I assigned initially. So to format the data, we need to use the QCC groups. So when you run it, the observations, and now you can see that there are 5 columns together and 25 rows, and this one means that sample 1 contains 5 observations, sample 2 contains 5 observations, and as follows. And this one is to run the data again, and now we need to create the X bar R chart. Run. So this is the X bar chart. The number of groups is equals to 25, and the center line is 20.936, and the lower control limit is 18.6980, and the upper control limit is 23.17399. And now we would like to create the R chart. So from the R chart, we can see that the number of groups is equals to 25 and the center is 3.88 and lower control limit is equals to 0 and upper control limit is equals to 8.2041. But from the chart we see that there are two red points, so it means that there are 2 points which is out of control, which is point number 13 and point number 19, and we need to delete the two data. So from here, we would like to repeat again the steps in the previous. And now I would like to clear all the block again. And now we assign that the new data is the data that do not contain data number 19 and data number 13. And I run. So the new observations contains only 115 observations. And the steps is the same as previous. So for the new X bar chart, we can see that the number of groups is now equals to 23 and the center becomes 20.86087 and the lower control limit is 18.95492 and the upper control limit is now 22.76682. And now we would like to run again for the R chart. So from the R chart, we can see that the number of groups now is equals to 23 and the center line is 3.3043 and the lower control limit is equals to 0 and the upper control limit is equal to 6.9869. And we can see that all the point is in the control limit, and we can say that the process is under control.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aidi Daniel and I'm going to be showing you guys the S bar S chart. Okay, so let's look. Okay, so first what we need to take note is this. Determine whether the points are in statistical control. Before you do anything, you have to start with the S chart. Then you can go to the S bar chart. First, you need to make sure that the S chart is in control, and then you can go to the S bar chart. If not in control, then you have to investigate the special causes and take appropriate remedial action to eliminate the special cases. Okay, what you got to do is remove the out of control points for which the remedial actions have been taken to. Remove the special causes and use the remaining samples to find the center line, the upper control limit and the lower control limit again. Okay, so this is the control limit for the S chart. What you have here is lower control limit equal to B3 times with the S bar, center line equal to S bar, upper control limit equal to B4 times with the S bar. Okay, so let's just go right ahead to the question. Okay, so this is the question. This is the task given. Okay, so there are 20 samples. There are also 20 sample mean and sample standard deviation. What we got to do now is do the S bar S chart. Okay, so let's go to the R Studio. Okay, so this is the coding for the S and bar and S bar chart. Okay, so what you gotta do first is library QCC, the package for the quality control charts. Then do this function SD. Then you put every single sample standard deviation of the 20 samples, and then do the function mean SD to find the S bar. Okay, so this is it. When ST equal to 4.79, then find the upper control limit equal to B4 times with the S bar. Before is 2.266 times with the S bar, then you get 10.85414. Then continue with the lower control limit. The same thing, but B3 times with the S bar equal to 0. Okay, so at the end of the coding for the S chart, you got to do this function as QCCSD type S bar dot one to find or to get the S chart. Okay, so this is the result for all the 20 samples. As you can see, everything is followed by the upper control limit and the lower control limit. All the data are in the control limit. Okay, so now we can continue with the S bar chart. The coding for the S bar chart is just the same as the S chart. The one different thing is just this, the variable ST and S bar. The same as before, we manually insert all the 20 sample min and then continue with the min S bar, then you get the value for the S double bar, which is 37.175. Continue with the upper control limit S double bar plus with the A3 times with the S bar, which is 1.628. There you get the value for the upper control limit 44.97312, then the lower control limit 39.37688. There you go. Then finally do the QCC S bar type S bar dot one with the limits to find or to get the S bar chart. Okay, so this is what we get. Okay, it's lagging. Okay, so this is it. This is the S bar chart. As you can see, all the 20 samples are in here. 20 sample min. Okay, so all the 20 sample min are in the control limits. So what if it's not in the control limit? Like I said before, you need to remove the out of control points and then do the calculation for the upper control limit, the center line, and the lower control limit again. Okay, so that's all for the S bar S charts. Let's continue with the next.